Dear participants, I would like to welcome all to you the Disruptive Technologies in Sustainable Aviation panel. Today, we have distinguished panelists from academia and industries to discuss disruptive technologies in sustainable aviation. The panel is organized by AIAA, SARES, and EATS. Firstly, please let me briefly introduce myself, then turn to the panelists. I am full professor at the Aviation Faculty at Eskisehir Technical University, Turkey. In addition, I am director of Civil Aviation Research and Application Center of and serve as the director of Prototype Center at Eskisehir Technical University. I am also the founder and president of SARES, International Sustainable Aviation and Energy Research Society. My research area is sustainable aviation, aircraft propulsion systems, gas turbines, renewable energy, battery management system, and UAV. I have taken part in numerous EU and non-EU projects in these topics as a researcher, consultant, and project manager. Also serve as an editor-in-chief International Journal of Sustainable Aviation indexed by Scopus and Web of Science, and International Journal of Aviation Science and Technology, and guest editor some other international scientific journals. I am author of over 300 journals, articles, and 40 books. The next, I asked Andreas Bierig from DLR to introduce himself. Andreas.
Thank you. Yeah, my name is Andreas Bierig. I am the department head for safety critical systems and systems engineering in the Institute of Flight Systems in the German Aerospace Center. We are located in Braunschweig, quite in the middle of Germany. Yeah, I'm in DLR since 2008. I started working over there directly after obtaining my master's degree in mechanical engineering. I specialized in electrical machine design, automation technology, and mechatronics. After that, I started work on several projects in DLR related to hypersonics, related to UAVs, but also related to electrically propelled aircraft. In 2012, I became the group leader for control technology and monitoring technology in our institute, and since 2016, I am the department head. Yeah, I also have a degree, a master's degree in business administration, where I specialized in strategic management of research facilities, and I'm also a research officer in the German Air Force, dealing there with innovation management for new aircraft design.
Thank you very much. Now I turn to Professor Ruxandra.
Yes, hello everybody. My name is Ruxandra Botez, and I'm working at Ecole Technologie Superieure, part of University of Quebec in Montreal, Canada. And I'm a full professor and also Canada Research Chair in aircraft modeling and simulation technologies. Also the founder and the director of the LARCAS laboratory in active controls, aeroservoelasticity, and avionics. We are working in the laboratory with 4 equipments, like 2 flight simulators of the highest level D for Cessna Citation business aircraft and for the CRJ 700. And also we have a wind tunnel as well as UAS, so a drone from Hydra Technologies. So our research is actually in modeling and simulation technologies, but also validated with experimental tests. So basically wind tunnel, flight tests, and also we work a lot on the morphing aircraft technologies as well as on flight trajectories optimizations. For sustainable aviation. All our projects are, most of them are funded and realized in collaboration with aerospace companies in Montreal and internationally known, like Bombardier, CAE, Bell Helicopter, Textron, and Thales, CMC electronics, forgot if I said or not. And yeah.
Thank you. Utku Kale.
Oops.
Thank you very much, dear professor. And this is Utku Kale. I am working for Budapest Technical University as an assistant professor at the Department of Aeronautics. And in addition to this, I am also working for Amsterdam University of Applied Sciences, HABEA, and also Vilnius Technical University in Lithuania as a scientific researcher. In addition, I am also working for European Commission in the unit of mobility and transport as an expert. At the top of that, I am also serving as the president of SARES Hungary, and also I am a cadet pilot on Airbus 320. And from resource sides, the area of main interest is mainly human factors in aviation, cognitive mobility, and air traffic management. That's all from my side. Thank you.
Thank you very much. Gökçin Çınar.
Hello everyone, Gökçin Çınar. I'm an assistant professor of aerospace engineering at the University of Michigan. I mainly work on system design, integration, optimization for sustainable aviation concepts, electrification, hydrogen-powered aircraft, or all the other concepts that disrupt the way that we design aircraft and integrate the propulsion systems into the airframe. I also lead the Michigan Initiative for Sustainable Aviation, which is a center for research and education at the University of Michigan.
Thank you so much.
Hello everyone.
Deniz Deştan.
Hello everyone, this is Deniz. I am environmental engineer. I have been working as a corporate sustainability management manager at Turkish Airlines. My base in Istanbul, Turkey. I manage and coordinate all action regarding all dimensions of sustainability within the company. I am also responsible for ESG performance of the company. And in addition, I am responsible for the conducting GHG report, sustainability report, task force climate disclosure report, and CDP. And lastly, I would like to mention manage the process concerning sustainability performance evaluation, such as S&P, Financial Stock Exchange, and MSCI. Thank you for your attention. I hope it will be a very fruitful meeting, a fruitful discussion for all of us.
Thank you, Vivian.
Good afternoon, everybody. My name is Vivian Sabo. I was coming today here from Papa, Hungary. I would like to start my introduction with my background. I get my bachelor degree in the Hungarian military system as aircraft weapons engineering, and my master's degree in safety engineering at the Óbuda University in Budapest. And I'm currently also studying my second master's degree as occupational health and safety engineering in Budapest at the Óbuda University. My first job was with the Hungarian military. I was working on helicopters, weapons system as an engineer on Soviet helicopters such as the Mi-8, Mi-17, and the Mi-24. Back 2017, I joined Boeing in Hungary, and I worked on the C-17 program as an avionics technician for 6 years, and after that I get the position at the company for the C-17 international sites as environment and health and safety professional, and I'm responsible for Canada, Hungary, the Middle East, such as UAE, Kuwait, Abu Dhabi, Qatar, and the India sites. My responsibility is create a safe working environment and keep up with each site the regulatory compliance. Thank you.
Thank you so much. Dear participants, sustainability refers to the ability to meet the needs of the present generation without compromising the ability of future generations to meet their own needs. It involves balancing economic, social, and environmental considerations to ensure the long-term viability of our natural sources, social systems, and economic systems. Yes, next please. Sustainability is critical in the face of the, major global changes such as climate change, biodiversity loss, resource depletion, and social inequality. Next, please. Sustainable aviation is the practice of reducing the environmental impact of air travel. This includes improving fuel efficiency, reducing emissions, managing noise pollution, and minimizing waste. Sustainable aviation also includes the development of alternative fuels, such as biofuels, which have a lower carbon footprint than conventional jet fuels. In addition to technical advances, sustainable aviation requires collaboration between airlines, governments, and other stakeholders to establish regulations, encourage innovation, and support sustainable travel practices. The aviation industry has increasingly focused on sustainability in recent years. This panel, hosted by SARES, Sustainable Aviation and Energy Research Society. So, I would like to, next please, I would like to give some information about the International Sustainable Aviation and Energy Research Society. SARES was established in 2015. Next, please. Main objectives are SARES research into green and environmental friendly energy resources and aviation technologies. SARES organizing symposiums, publishing books and journals. Next, please. Every year, as SARES, we are organizing 4 symposiums. One of them, International Symposium on Sustainable Aviation. Firstly, we organized the symposium Istanbul, then Istanbul, Kiev, Rome, Budapest, Kuala Lumpur, Bangkok, Melbourne, Tiananmen, and this year we will organize the symposium Belgrade in October. I'm inviting all of you this symposium. Another symposium, International Symposium on Electric Aviation and Autonomous Systems. Another symposium, International Symposium on Aircraft Technology, MRO and Operations. This year, we will organize this symposium, Ho Chi Minh City, Vietnam, on August. Last symposium we organized every year, International Symposium on Unmanned Systems, AI Design and Efficiency. This symposium first organized Kiev, then Washington, Madrid, Stockholm, and this year we organized in May this symposium at Baku. Next, please. Next. Sorry, next. Next. Yes. As SARES, we are publishing 9 books every year, all of them sustainable aviation with Springer. We have a contract with Springer for 5 years. 4 of them, these books, symposium proceedings. Next, please. 5 of them edited books. Next, please. And next, please. Next, please. Thank you. Also, we are publishing journals. One of them, International Sustainable Aviation Journal, published by Inder Science, indexed by Scopus and Web of Science. The other journal published our society, International Journal of Aviation, Science and Technology. Next, please. As SARES, we are giving awards every year. Science Award, Lifetime Achievement Award, Company Award, Young Researcher Award like that. Next, please. As SARES, we are opening chapters all over the world. For example, Australia, Canada, Greece, Hungary. Next, please. Malaysia, Netherlands, Slovenia, Serbia. Next, please. Spain, Sweden, United Arab Emirates, Ukraine, Taiwan, Vietnam, Singapore, USA, Poland, and Lithuania. Yes, this year we organized all SARES symposiums and delivered the SARES awards in memory of Ming Cheng. Ming Cheng started the collaboration between AIAA and SARES before he passed away. Ming was a pioneer throughout his career in aeronautical engineering. Ming's leadership driving AIAA to address the important challenges of the aeronautical world will be long remembered. His AIAA service is directly responsible for the Institute's aeronautics domain leadership. Ming always supported the SARES and SARES symposiums with his presentations and aviation knowledge for many years. Next, please. Ming Cheng took part in several meetings during the preparation for SARES panels in IIAA Aviation Forum. Ming will be missed and be always remembered by us so much. On behalf of SARES, I express my deepest sympathy and condolences to his family and friends. In this slide, you see some photos taken during the SARES panel preparation meetings with Ming Cheng, Jim, Professor Max Platzer, and Utku. Next, please. Now, this is my last slide. Now, let me explain the panel structure. In the first round, I will direct general questions in field of disruptive technologies in sustainable aviation based on their expertise. In the second round, I will ask the technical questions. In the third round and last round, the questions will be received from the audience. As you see in this slide, 4 minutes will be allocated for each panel in the first round, and 7 minutes will be given to each panelist in the second round. Now, I will turn my panelists to ask their first round of questions. First question I will ask to Andreas. Dear Andreas, what are the technical challenges and difficulties in sustainable aviation based on your expertise?
Yeah, thank you. From my perspective and based on my expertise, to make the aviation sector a real sustainable, what, for example, or mainly means that we produce net zero emissions, especially in CO2, we are facing huge technical challenges. At the moment, aviation still contributes approximately 2.5% of CO2 to the worldwide man-made CO2 emissions. It seems to be not that much, but it's in total numbers, it's a huge amount, and it's quite hard to reduce that because if you have a look on the aviation sector, traveling by aircraft is especially attractive if we travel on the long-range distances, and on long range at the moment, we do not see that many technologically alternatives to traditional propulsion systems, except of replacing the fuel by a sustainable aerospace fuel. If we consider more shorter distances, medium and short range aircraft, then we have some other alternatives, but all of these have their own technological challenges. First, I will talk about the sustainable aerospace fuel. It seems to be straightforward to exchange the fuel in the aircraft, but however, to produce fuel from electricity demands a lot of energy, much more energy than we need at the moment to just get the oil out of the earth and then produce it to jet propellant. By the end of the day, this will mean that it becomes much more expensive flying with an aircraft compared to today, and there's also still lack of production facilities, especially large-scale production is not available at the moment, and it will still take a lot of time until we have this available and can replace aerospace fuel with a sustainable alternative. If we talk about shorter range aircraft, we might consider hydrogen as an alternative. For long range, it's not a good alternative because the volumetric energy density is too low. So we would need a huge volume of this propellant in the aircraft, and but if we consider shorter ranges, it might be an option. However, hydrogen changes more or less everything in the aircraft. So we cannot just put it in the aircraft like traditional fuel. So we need to liquefy it to get it or to bring it on a volume which is really good to transport it. And liquefying might be done by pressurizing it or cooling it down. For the aircraft, we need to cool it down. Otherwise, the tank would be very heavy And to handle liquefied hydrogen, this is a very big technologically challenge, since we need to cool it down until 20 kelvins, and we need the material to handle this and so on. Then if we transfer it in electricity, we need a fuel cell. Fuel cell produces only half of the energy as electrical energy, and the other half, which comes from the hydrogen, is heat, and we need to get out the heat of the aircraft, and then a fuel cell operates only at low temperatures, and this is also a problem to get the heat out. We need to find technical solutions for that, and they are not available today. And all the stuff we would need, fuel cells, tanks, also electrical motors, are still at the moment too heavy and not really flight proven that we can put it on a commercial aircraft. Batteries are only an alternative for very, very low-range aircraft. We might see them in future in the sector of urban air mobility, where we have very short ranges, but also there we need to handle problems with or challenges with example, fire risk, cycle stability, and also the energy density of the cells. What is my research company, the German Aerospace Center, doing in this sector? We are doing a lot. We have developed a research strategy which implements the European Green Deal. So we want to provide the technology which is necessary for reducing the CO2 emissions of the aviation sector until 2050 to net zero. We do this technologically open. That means we do not focus on one technology. We focus on all, at least the three I mentioned. And for that, we recently started a very huge project to improve our research facilities, our infrastructure. It's called Uplift, where we set up a lot of ground-based test rigs for proving technology in the hydrogen sector, also electrical engines and all the related systems. And we also purchased a research aircraft, and this is a very big cornerstone in DLR's research strategy. We do not only conceptualize and ground test technology, we also bring it into the air. We flight test it, and this is very important to gain the experience we need to see the challenges which need to be overcome for certify all this technology and bring it into a real application. DLR for that operates Europe's biggest research fleet, and now we have one unique aircraft which is really dedicated to sustainable aviation. Because by the end, aviation technology not only means, or research in that area not only means that we have to show that technology works, we also have to show that it works safely, and this is a very big issue and a big challenge for the future.
Thank you so much. Now, next question goes to Ruxandra from ETS. Dear Ruxandra, based on your expertise, what challenges and risks are associated with implementing disruptive technologies in sustainable aviation?
Okay. So based on my expertise, if I look into the challenges and difficulties in sustainable aviation, I would first start mentioning the optimization of an aircraft and engine, which everybody works in the companies, right, on, and we are also working. We're also trying to do morphing. Well, morphing is very close to optimization, of course, of an aircraft and an engine. So what I would say, first of all, is the multidisciplinarity of the fields in aerospace. So you have mechanical engineer, electrical and computer science engineers. So the technical challenge in morphing is the interaction between aerodynamic structures and controls. So you have people from different departments with different views, and it's pretty difficult sometimes to interact due to confidentiality or protection of data and so on. So I think that's the most difficult part in sustainable aviation and actually in aviation. So our multidisciplinarity and our different departments. So we had projects with companies on morphing aircraft, and we have seen like the difference even in academia level, but also in industry. And then another aspect in multidisciplinary area is the other huge axis we are working on. It's flight optimization. We work with CMC Electronics. Honeywell has also a lot of work on this area, and I know they work and they had very good results with Tarom Airlines in Romania, because I'm originally from there. But I've seen like papers, and I worked also in collaboration with airlines. So once again, the multidisciplinarity in that area is the interaction between airlines and aircraft manufacturers, and of course the pilots, to make this working. Of course, flight trajectories are optimized, aircraft and engines are optimized. So what we are trying to say is that everybody has to work to optimize more, right? To get more reduced fuel consumption and greenhouse emissions. The other thing is also to have better, what we are trying to do in our lab with our flight simulators level D, that they are equipped with highest level of certification. Is we use these flight tests also to validate our flight models and flight control models, or whatever we try to do. And the idea is also, as much as we are all working towards much better flight models, we could help in minimizing flight tests but still the flight tests, they don't take so much time like for a prototype. But anyway, the idea is also to optimize the prototypes and the models on the prototypes, right? So it reduces also the time of people like who are working on them. I hope it was clear. So
thank you. Now coming next, I would like to turn to Utku Kale from BME. Firstly, I congratulate you on your appointment as a European Commission expert in the unit of transportation and mobility in Brussels for a 5-year term. Dear Utku, can you introduce the Bright Sky project to our audience and explain its research activities and key objectives?
Thank you very much, Professor. First of all, I would like to tell thanks to Professor for the organization of this great panel. Let me talk a little bit about Bright Sky project. Bright Sky is a project funded by Netherlands Aerospace Industry and Dutch Environment, aiming at advancing the sustainability in aviation. And one of the key important is that if you are checking the partners who are involved in this project is Netherlands Aerospace Industry, Kale, Amsterdam University of Applied Science, and jet support MRO companies, in addition to this Airbus and TU Delft. And one of the main objective of the work package 5 within this project is to create digital cockpit simulation and smart training, where I'm also involved in these work packages. Basically, we are trying to come up with a digital cockpit that serves for maintenance and mechanics and ground operators. And because there are a set of problems in that regard, first of all, I can list these things into 3 categories. And first, availability of the flight simulator for MROs. If you are checking in Europe, especially from mid-sized MRO companies, that they don't have flight simulators in their base, and they need to train their MRO staff and ground engineers in the flight simulator. However, they don't hold flight simulator in their base. For this reason, there are 2 options. Either they need to send their ground staff to a contracted company to get them trained, or also possible that they can train them in the real aircraft. I have also witnessed some of companies, really they don't have any flight simulators in their base, in the MRO companies, and they only provide training in the real aircraft. For this reason, there is a really huge need to have one virtual reality flight simulators, which can be really beneficial for MRO companies. Of course, that would be also beneficial for pilots and other stuff like ATM stuff as well. And another problem is about the COVID. Before the COVID, everything was going well, and everybody, all the MRO companies was investing in each of the fields. However, once COVID hit, they start to cut the cost. And to do this, first they started from the experienced MRO staff members, that's so-called old gen staffs. And also they stopped training the young gens. By this way, once the COVID ends, they realize that there's a huge gap. They don't have experienced MRO experts. Also, they don't have young gen. So even though they start taking new stuff, they didn't find a lot of instructors who can train the new generation. So they realized the importance of managing those issues indeed. And the third, and I think one of the main problem also, that retirement of the old generation. And according to regulations in Europe and the forecasting, about 20–30% of MRO guys are going to be retired in the coming 5 to 10 years. And the problem is about the young gen again, that there is no high motivation from the young gen to take over this role. So I think not shining days waiting in the aviation industry from the mechanical part, which also highly related to environmental effect and sustainability. I think for now, that's all.
Thank you so much. Next, let me turn to Gökçin Çınar from University of Michigan and MISA. Dear Gökçin, what challenges and risks are associated with implementing disruptive technologies in sustainable aviation?
Well, I think Andreas did a really great job of summarizing the challenges in the technology, and Ruxandra mentioned the need for optimization. So I would like to approach it from a different perspective while acknowledging all those challenges. When you go around the forum, you will see a lot of sessions, technical sessions, panel sessions, talking about the technical challenges, may it be electrification, hydrogen, or something else. So that gives me hope that these technical challenges will be solved one day. Maybe it's tomorrow, maybe it's decades later, but I think the technical challenges are not the biggest challenge that we are facing today. I think it's the integration of all these activities, not only in terms of what the engineers are doing, but also, is the system ready? Is the aviation ecosystem ready to adopt these technologies? And the main problem with this is isolation. When we work on our problems, we usually don't think about, when I say we, let me just give an example from myself. I'm an aerospace engineer. I don't know much about economics, or I don't know much about, for instance, airline operations or airport structures. I work on aircraft design, and when a disruptive technology like electrification or hydrogen comes into discussion, I immediately think about, okay, I'm going to find the best way to use this technology in the aircraft, and I'm going to make my aircraft amazing. It's going to be feasible. It's going to fly from point A to point B by spending this much energy and so on and so forth. But I don't know if when I say this aircraft is going to fly from point A to B, if the airline will accept that. And the reason why is, again, going back to what Andreas was saying, the challenges with or limitations with range, for instance, for electrification. Well, when you compare a hybrid electric or fully electric plane against a conventional plane today, obviously you don't get that range benefit of the jet fuel that the jet fuel gives you. But I see that the problem is this is not a fair comparison. We had decades to optimize the aviation system as we know it today. And all the system has been built on the fact that our engines burn fossil fuel. So when you change that propulsion system, not only how the aircraft looks like, what the aircraft looks like change, but also how it operates, I think, needs to change. So we need to rethink about how we integrate these technologies into the aviation system from an infrastructure perspective, from an operation perspective, from sourcing the energy perspective. And the main issue with this is we cannot do all this in isolation. There needs to be a coordinated effort. Because if I design an aircraft and then somebody builds it, and then somebody tries to sell that aircraft to an airline that did not optimize their network for that aircraft, or they don't have the right infrastructure to support that aircraft, then everybody loses. So again, I think this is a complex systems challenge, this is an integration challenge, this is a coordination challenge.
Thank you. Next, let me a question to Deniz Daştan from Turkish Airlines. I am well aware that Turkish Airlines, one of the leading airline companies worldwide. Can you talk about the sustainability efforts carried out in airline companies in generally?
Thank you, Professor. Actually, when we talk about sustainable aviation, that means reimagining our approach to everything from fuel efficiency to carbon emissions. According to the two major organizations of the aviation industry, IATA and Ecole, have set targets reduced to negative impacts of the aviation. The aviation industry demonstrates its determination on combating climate change with net zero emission by 2050. It is also announced by IATA and also Ecole. The industry achievement of net zero depends on actually effective climate policies through a combination of sustainable aviation fuel and hydrogen use, new technologies, operation improvement project, carbon offsetting, and carbon capture implementation. All these implementations are considered to important to achieve in line with 1.5 degrees target of the Paris Agreement. In aviation industry, there are various mainstream scenarios for achieving long-term emission reduction target. These levers can be grouped into the two main pillars, such as sectoral implementation and also out-of-sector implementation. When we actually look at the sectoral implementation, we can mention three main implementations. One of them is technological developments, such as hydrogen and electrical propulsion aircraft or new generation aircraft. The second, optimizing operation and infrastructure, such as ground and flight optimization projects, and air traffic management implementation using lighter materials in aircraft construction and reducing unnecessary weight on flight. And implementing more direct flights. The third one is the most prominent elements for achieving long-term emission reduction target is sustainable aviation usage. When we look at the out-of-sector implementation, we can mention global market measured issues such as carbon offsetting reduction scheme for international aviation and also emission trading systems, and offering to option passengers to invest in environmental projects. The second one, carbon removal technologies. Although carbon capturing is far from being fully scaled up, but it is still exciting technology for emission reductions. Taking all action is crucial in the decarbonization journey of the aviation industry, but as I mentioned before, SAF is the major element for achieving long-term emission reduction target. There is high demand for SAF by the airline companies, which doesn't meet current supply. And SAF limited availability and extreme high costs are obstacles to overcome on aviation decarbonization pathway. And also safety is the top priority of the airline operators. 11 SAF pathways were approved by the ASTM International, and some other pathways are undergoing laboratories evaluation for the applicability. And the major airframe and engine manufacturers are working to ensure that all aircraft can safely use 100% SAF by 2030. However, feedstock availability is a great importance at this point. While used cooking oil, plant oil, municipal waste could be used as a feedstock of SAF, types and quantities of SAF feedstock should be increased to scale up of SAF production within principle of not competing with the crucial needs such as wood, water use, land use, and also food. According to the IATA, the production of SAF accounts for only 0.80% of global jet fuel consumption in 2023. And this amount is used entirely by the airline operators. The percentage must increase minimum 65% to achieve long-term emission reduction target. SAF production has not reached a sufficient level in response to the demand of the sector. Navigating this challenge requires a unique blend of technological developments, regulatory compliance, and also community collaboration. Collective action from manufacturers, suppliers, airlines operators, financiers is essential to scale up SAF production and usage, as well as to overcome economic and technological challenges. That's all.
Thank you so much. Now, let me ask a question to Viviane Sabo from Boeing. Dear Viviane, how to improve workplace safety in sustainable aviation?
In sustainable aviation, we need to first provide a good safety system. As EHS specialist who is doing risk assessments and analyzing the workplace safety. And we need to have a good management system which is promoting at the workplace the safety. We need to train and educate our employees. If they see something, then it's supposed to be a positive safety culture. They should reach out and they can express their thoughts if they think it's something is unsafe within the company. And we need to have a good emergency preparedness. If something is happening within the company that the employee needs to be trained and educated, how do they reply back for emergency situations? And we need to mitigate the risk as a safety professional and lower as much as we can. We need to be familiar with the regulations, and the regulations in Hungary. First we take the basic Hungarian law, and after comes the government law, and we have separate ministry which can take some decrees, and after comes the company internal policies, and we cannot overwrite the law with the internal company policies. If some of them is more stricter than the other, then we need to keep both of them. So it means if your company internal policies is located within the European Union, but your company is international sites, then your local law will go into that company internal policies, and in this case, it's both will be applied. It doesn't matter where you are within the world, but you cannot overwrite any internal policies. So the main is the people, management, qualified employees, education, training, emergency preparedness, and taking consideration the law for the regulations, the local regulations. Thank you.
Thank you so much. Dear participants, we finished the first tour on time. I would like to thank all panelists because of the time. On the second tour, actually, I prepared 2 questions every panelist. I will ask the first questions in the second round. If you have time, I will ask the third questions. You can answer the questions in 4 or 5 minutes every questions. We have time. I will follow the same name order now in the second tour. I will ask firstly again Andreas. Dear Andreas, how would it be possible to maintain high safety standards in aerospace when disruptive is introduced?
Yeah, thank you. To maintain the safety standards or the safety goals and objectives in aerospace from a technical point of view, we need to do still a lot of work if we want to introduce disruptive technology. At first, a few words about safety in general, what we want to achieve when we introduce a commercial transport aircraft, and then I will mention a few strategies which could be followed to realize or to approach also this with new technology, with disruptive technology. Yeah, nowadays our goal is, or at least this is what we have to demonstrate to the authorities, that an aircraft does not more often produce have an accident, a catastrophic event, than once per 1 million flight hours, 10 by the power of -6 in its life. We consider that most of the accidents are not caused by the systems or by the hardware of the aircraft. Most of the accidents are caused by the human being in the cockpit, and we only allow one accident caused by a technical failure per 10 million flight hours. This is what we need to prove, and this is what we want to have at least. Nowadays we are better with modern aircraft, and there's a principle in safety in aviation industry. If we introduce new technology, we want to have or achieve at least an equivalent level of safety. That means also for new aircraft with disruptive technology, for example, a fuel cell, and which is powered by hydrogen. We also want to have this, and this is not that easy to demonstrate and to achieve, because how can we prove these numbers? Normally, this is done based on experience with the systems components, with the system technology, with the technology of the components, and so on, where we know, okay, how often under the operational conditions of the aircraft does a component fail, and then we can implement it or incorporate it in our safety proof and also into the design. Since we do not have aircraft which are propelled by hydrogen at the moment and with fuel cells, at least not in a high enough number to get such statistical numbers from it, we have to think about different approaches. What can we do with disruptive technology? In the past, when we developed aircraft, we had the benefit from technology which was already operating in complementary markets, automotive or in other industry. Computers, for example, were already quite well-known systems and components of the computers, how they fail and how often they fail. With hydrogen technology, for example, that's not really the case, so we need to gain this experience, and we have different possibilities for that. First is extensive ground-based testing, so that we put the components with the related technology on ground test beds and run them and see how they operate, and hopefully we can explore the margins and incorporate them then into the design. However, ground-based testing is limited since normally we are not able to represent all the operational conditions of an aircraft. Temperature, air density, speed, altitude, radiation, and all the things. So somewhere we need to go into the air with it, we need to fly. With disruptive technology, we should really think about to bring it into lower risk applications. There could be, for example, unmanned systems, unmanned aircraft where we have new disruptive technology first on board, since the risk that people die when an accident happens is quite low. An example could be transport aircraft for goods, and also military applications are sometimes quite good for having new technology on board because the safety standards are there a little bit lower than in the commercial market. On the other hand, pilots, for example, in a fighter aircraft, which is probably not a good example for hydrogen technology, but however, they have an ejection seat, and so they have opportunities to leave the aircraft if things fail. Another strategy would be to introduce disruptive technology in an incremental approach. To not only rely on this new technology, but also to have backup systems based on well-proven technology, and at least the ability that if the disruptive technology fails, that we can set the system based on the disruptive technology in a safe state. So it might fail, but it should be safe, and we can rely on a backup system. This would also be an option. And then stepwise, we hopefully and probably approach a stage where we know that much about the new technology that we can rely on it and build a new aircraft only based on this disruptive technology. If we then it can call still disruptive technology is a philosophical question, but this could be options to approach the safety standards.
Thank you so much. Now I would like to turn to Ruxandra again. Ruxandra, you know, morphing wings is one of the disruptive technologies. What technologies are used to enable morphing capabilities in aircraft? Can you provide examples of specific morphing technologies used in aircraft?
Well, I think most of, morphing from my understanding, what we are, as I said earlier, like it corresponds to optimization of an aircraft and engines, but we can have like a sort of passive, which means like we know that we work on the optimization, so on the changes of the surfaces, wings, horizontal tail, and so on. But the one that is harder to implement today on an aircraft is the morphing, like the active control morphing, where you have, let's say, a wing and it's controlled with actuators and with a whole system of control. And it depends what type of actuators you have. So, for example, we had two big projects with Bombardier, so with industry and Thales, and we had in the beginning smart material actuators, which were implemented on conceptual design. So we had absolutely no structural constraints. So the results were very good, like everything we predicted in terms of aerostructural optimization was achieved, so all the aerodynamic coefficients and so on. We got also like 40% like reduction in like more linearity of the flow. So the idea was to improve the aerodynamic performance by working on aerostructural control optimization of this wing, which would move, thanks to these SMAs. But the SMAs has drawbacks, so they had like some disadvantages from heat point of view. However, the surface, as I said, was very easily deformed, while in the second project we based our research on a prototype already existent, so we had a lot of structural constraints, so of course the gain was much less than in the first project. Of course, we validated our morphing structures with and control with wind tunnel at NRC test, so that's why I said there were different type of results. So once again, the problem was like always like the interaction between disciplines, aerodynamic structures, controls, they would go all together, and integration as she was just mentioning. So it goes with it, with the optimization of the whole wing. So that's why I think it's hard probably after these projects to say, okay, it's easy to implement an active control system on a morphing wing in the air. So there are advantages and disadvantages. So I would rather go into the optimization from the first stage of aircraft design. And not later, because if you do it later, you have more structural constraints. So it's like a two-way job. So that would be like the big challenge in this type of projects of morphing. Most of these active morphing capabilities are studied, I find, still in academics, so they are not so much implemented in the real world of companies. I think we can define morphing even by the wing blended body today, so they call that morphing, or even what the Wright brothers said, you know, since the beginning, there are people saying, well, that's also morphing related to today. So, but the morphing, the active morphing is still difficult to be implemented, the one that we are working in our lab. So, so it's still a big challenge. We still try to do it like, you know, many people do still morphing leading edge. They think it's much easier to attain, but once again, we talk about the interaction between disciplines, and the main challenge is still the structure. So we try to work with composites, but it's the manufacturing. So it's not only the design, but then, so our project was 3 steps: design, manufacturing, and testing. So we found the manufacturing was even more difficult, because you really want to have zero tolerance for the aerodynamics results that you are expecting. So, yeah.
Thank you so much. Now I will turn to Utku again. Utku, here is your second round, first question. What is the impact of automation and aviation operator performance and its relation to sustainability?
Thank you very much, Professor. Today we are talking about the challenges in sustainable aviation. I will go a little bit further to human sustainability in aviation. First of all, on one side, everybody would like to have interesting and enjoyable environment, especially for pilots, to control the aircraft in a smooth way. But on the other side, if we are increasing the level of automation and technology, we are increasing and creating complex environments for their working area. So on one side, it's good that they are having control in an easier way. However, situation is start that if something goes wrong, if abnormal situation is happening or under emergency, pilots and air traffic controller will not able to take easy decision in these difficult circumstances, because we are highly leaving the decision to automation. And once things goes wrong, then the machine want to make decision on behalf of the pilot. And unfortunately, if you are checking the current training, as also a cadet pilot, I can tell that we are not having pilot training as the old generation. In my family, there are more than 8 pilots, commercial pilots, but they are all gens, so they don't consider the today's pilot training as the original pilot training because they had hand-on skills. But nowadays, unfortunately, this is not the case. Everybody would like to fulfill the minimum requirements in the pilot training, complete the minimum flight hours, like 200 flight hours for ATPL, then that's over the case. And on the other hand, there are some drawbacks. For example, due to high level of automation and intensive technology, the role of operator, aviation operator, is in transition from active controlling to passive monitoring. In case of the active control, as we discussed at the old gens, that they were able to take the control based on their experience, knowledge, tacit knowledge, and their mental situation. However, in the current environment, we are talking about the passive monitoring in the second chapter, which the pilots or operator, let's say, only is the element, passive element of the current system, and they only initiate the active control when is needed, when is necessary. And this also creates a big problem. Also, I would like to go a little bit further to Vivian's side. She deals with more the regulation, but I can also bring one challenges from the regulation side that let me give you one critical example. Let's assume that there is a pilot who is speaking with his rabbit always in the garden. And the neighbor is noticing that the pilot wearing uniform, talking always with the rabbit before his duty. And let's imagine that this neighbor informing this situation to air traffic management, what's happening. Unfortunately, there is no any clear regulation to take any circumstances towards the pilots. However, if the same pilots make an accident or incident, all piece of information becomes valuable. That means that we are always waiting the end part, as also we are checking the black box, right? Once everything over. But what I'm also working in the European Commission and in some of the affiliated universities that I stated, that we should try to build one system which we should understand the pilot, decision-making way and the mental load. I am calling this like there is a file inside of the brain of persons. Basically, our aim to reach that file and understand what's going on in the real circumstances. We do this, we try to understand and assess those loads, let's say, by measuring the operator loads through some devices, medically accurate rated devices like eye trackers, heart rate monitor, electrodermal activity, and so on. So basically we try to understand their load system in real environment. Because if we are checking their medical certificates that every 6 or 1 year they need to renew based on their ages and some criteria, it doesn't give a clear sense for us, because the medical certificate is kind of that you go for a check. But let's assume that I'm a pilot. Today I had a fight with my wife, I go to duty. Of course, no one expects me to perform same like a normal day. So there should be some different system in the cockpit which can measure my mental situation in real time. That is the main concept. And also I took part in some project related to single pilot concept and operation. And this is also one of the main problems from the regulatory side, that how to license, certificate those single aircraft persons, or reducing the crew member from 3 to 2, 2 to 1. It is again same situation, that what if the pilot is not able to take the routine action? And if he is having some health problem, he is getting stressed or being under aroused, etc. For those situations, we should come up with a load measuring system. I think those decisions also will be highly affected the sustainability, because if they will have better decision, they will take better roads, they will, the number of accidents will be decreased, and so on. And if you are checking the statistic, as we know that according to NASA Aviation Safety Report, 85% of all aviation incidents and accidents track to human factors. And also, in the morning, there was very interesting speech given by the NASA director at the EAT forum. In the morning of the very first speech of the NASA director was that the demand of air transport also increasing. In Europe, I know from the European Commission that it's going to reach to 44%, which is equal to 6 million by 2050. But NASA director already gave a general frame that is going to reach to 60%, which is equal to 10 million per year. So it is even wider perspective for worldwide. And another issue that the number of air traffic also going to be much busier than usual, because we know that number of drones is going to be increased. We are talking about the air taxis nowadays, and also personal aircraft is going to be increased. So the daily life, what we are doing, all these activities on ground is going to move to the air. So that means that the air traffic also going to be complex, and in that perspective, human dimensions also need to be included each aspect. And we are working also for the ATM master plan in Europe as the European Commission to include some of those dimensions and the importance of human factors and human roles in the coming highly automated systems and high technology complex environment. Thank you very much.
Thank you. Dear Gökçin, I know you are leading MISA, Michigan Initiative for Sustainable Aviation. I would like to ask a question about MISA. What are some of key activities and projects currently being undertaken by Michigan Initiative for Sustainable Aviation, MISA?
Of course. Well, thank you very much for the question. By the way, I'm not the NASA director. I was just there at the speech that Utku was talking about. We had a slide about MISA. If we can bring that up, I sent one to Jim, but if not, no problem. So MISA, the Michigan Initiative for Sustainable Aviation, is basically an initiative undertaken by the faculty at the University of Michigan. And by putting this initiative together, we aim to bring people together. So earlier on, when you asked about what is the biggest challenge based on your expertise, I said, well, we need the coordination, we need to bring people together. So we said, okay, let's try to do that first within our university, and then let's try to go outside, because all the technologies that we are talking about for environmental sustainability, they require different kind of expertise, not just from an engineering perspective, but also from the energy experts, infrastructure specialists, policy makers, airline or airport representatives. We said we need all of these people at the same table. So we created this multidisciplinary center. I said for research and education. For the education part, we are offering now new courses for both undergraduate to both undergraduate and graduate students. We have new courses completely about new ways of thinking about sustainability and the technologies that come with it. But also we are implementing the sustainability thinking, it's like the systems thinking, sustainability thinking into our existing courses through different projects or assignments or discussions. On the research side, we already had a lot of research activities before we started the Michigan Initiative for Sustainable Aviation. But by establishing this initiative, what we aim to do is to collaborate with the people that we usually don't collaborate with in our research. We usually collaborate with other engineers, but when it comes to thinking about maybe the social aspects, or when it comes to the energy, where the energy is coming from, we really need to think outside the box, and we need to think about the collaboration. So in the University of Michigan, there's already an established ecosystem. There you go. Thank you. So there's already an established ecosystem. If we can go to the next slide. We already have a lot of people working on different parts of sustainability. We actually have a school of sustainability and environment. We have a global CO2 initiative. We have the Sustainability Institute. The challenge was that most of these existing entities within the university, they don't look at aviation specifically. So what MISA does is we bring the aviation-related problems to the table, and then we get the expertise of all of these people to solve these challenges. But within the university, you can only go so far. So we really need partnerships externally as well. Not only with other universities, other experts from other universities, but also the industry. So we have put together a symposium last year in September, and we invited experts from the industry and government, and we asked, what do we as academia need to do in order to help us achieve this goal of net zero by 2050? And we put together a roadmap, not a generic roadmap for sustainable aviation. You can find that in many places now, but a roadmap for what we in academia need to do. And what came out of it was basically a list of areas, a list of technologies, a list of problems that we needed to really focus on. If you can go to the next slide, you can see some of the key areas that came out of that discussion. So, and you see how multidisciplinary the environmental sustainability problem by just looking at this, right? On the one hand, you have the very conventional aerospace engineering related topics like aircraft design or propulsion systems, air traffic management. But when you look closer under the hood in all of those smaller bullet points, you see that there is much more expertise that is needed. In terms of maybe electrification or the energy sources or the infrastructure challenges, the certification challenges, and so on. So by establishing MISA, we said, okay, we want to create a consortium where the industry and academia works together in order to train our students to create a pipeline, and a pipeline where we train the next generation of the workforce, understanding the real world problems that the industry is facing. So that communication between the industry and academia is very important to solve that coordination challenge. But also through research, we are helping our industry partners solve some of the challenges in electrification, in hydrogen-powered planes, air traffic management. And when we cannot, in our own expertise, when we are having challenges to, find solutions, we reach out to the experts within MISA in order to collaborate together. For instance, people who are working on the social sciences side of the problem, or people working on the climate science side of the problem. We work together to find a coupled solution, because this is a highly coupled problem with multiple objectives, and by bringing these people together, we are trying to find a more realistic and more viable solution.
Thank you so much. Now I would like to turn dear Deniz. As SARES, we have a long-lasting relationship with you and Turkish Airlines. I'm well aware of your activities in the field of sustainable aviation at Turkish Airlines as the Director of Sustainability. Aviation's environmental sustainability climate commitments have further increased the priority of the environment on the industry's agenda. As we know, Turkish Airlines announced its 10-year strategic plan for last year, and in this strategy, we see that you put sustainability in the center of your business model. Can you talk about your 10-year growth plan and your target of becoming a carbon neutral airline in 2050?
Thank you, Professor. As Turkish Airlines, which flies to the most countries in the world, we are on the way to become Europe's youngest and most modern fleet. and we are increasing our strength day by day. And if I mention about the result of 2023, we carried 83 million passengers on our flights to 349 destinations in 130 countries. And our total revenue was $20.9 billion US dollars. And we completed the last year with a fleet of 457 aircraft. And we continue our operation with over 33,000 employees. And while we plan to double our capacity by reaching over 800 aircraft in 2033, sustainability is one of the main pillars of our strategy. We aim to carry over 170 million passengers and fly to over 400 destinations in 2033. Four main pillars of our strategy are sustainability, growth, and profitability, business excellence and efficiency, digitalization, and also sustainability. As the airline flying to the most countries in the world, we carry out our operation with sense of responsibility towards environmental and society, aligned with our sustainability strategy. In this regard, last year we disclosed our long-term emission reduction target in our strategy. We aim to be carbon neutral airline by 2050. In 2033, next generation aircraft will consist at least 95% of our total fleet, and we will reduce carbon emission between by 15 and 20% compared to the older generation aircraft. We currently use sustainable aviation fuel in our flights, but we will enter into the long-term SAF-offtake agreement to support SAF production in our country with different SAF pathways. Through operational improvement project, we aim to save over 1 million tons of jet fuel consumption by 2033. When we look our savings between 2008 and 2023, we could prevent 743,000 tons of fuel consumption and emit almost 2,350,000 tons CO2 emission into the atmosphere. We are evaluating project investment that generate carbon emission reduction credits, and we will voluntarily offset our emission in line with regulation and our company targets. We aim to meet at least 5% of energy needs in our new buildings from renewable resources. Our new buildings have LEED certification also. We plan to invest in solar projects that can meet and compensate for our energy needs in the future. We recognize our role and responsibility in this powerful strategy, and we put sustainability at high level on our agenda. We have an internal high-level sustainability committee. It's chaired by our CEO, and all chief officers are members of this committee. And this committee meets at least 4 times in a year. And the committee carries out its activities to determine, review, and continues to improve Turkish Airlines sustainability strategy, sustainability policy, short, medium, long-term sustainability targets, and decide on the improvement project which actually increase Turkish Airlines sustainability performance. Besides high-level committee, we also established 4 different subcommittees taking into account our most material issues. In line with awareness and expectation of our customer, we launched our voluntary carbon offset program, CO2 emission, in 2022. The CO2 emission use ICAO carbon emission calculation methodology, and we provide opportunity to our passengers to offset their emission via this platform. And we offer 3 different portfolios on this platform, such as renewable energy, social benefit, and green world. And these portfolios serve 9 different sustainable development goals. And not only Turkish Airlines passenger, but also all airlines passenger can offset their emission by using this platform. And when the offsetting is completed, our passenger get their online certification from the platform. And if you want, they can also gift carbon offsets to their loved ones. Within scope of CO2 emission program, Turkish Airlines has also offset their employees' duty flights. And lastly, with this program, we aim to increase knowledge and awareness of the community.
Thank you so much. In this tour, last question goes to Vivian. Dear Vivian, how can workplace safety in sustainable aviation be improved?
I would like to talk about, as an EHS, environmental health and safety specialist, about European Union rules and regulations. The Montreal Protocol says that by 2050, the ozone layer can be restored as it was pre-1980s. And the European Union banned the halogenated fire extinguishers within the EU as a usage. So it's going to affect the aircrafts, since we are using halogenated fire extinguishers for the airplanes, such as handheld devices for the flight deck or the cargo or the passenger area. And we are also using this ozone layer destroyer halogen item for the APU, auxiliary power units, and the engines. So we need to find another solution which can be replaced for these fire extinguishers. There are several different chemicals exist for that. It can be just nitrogen or dry chemicals or water, but they have clean chemical agents such as the FM200 or the Novak 1230. And when we think about chemicals, we think that it has some inherent toxicity. So as a safety professional, we always focus on how we can protect our employees. And if there is no exposure of the chemicals, then there is no risk of, or there is a chemical is doesn't have any toxicity, then it's also have zero risk for the employees. But when it comes to risk assessment and regulations and policies, when we do the risk assessment, we need to track this exposure, and we need to also check the toxicity of the chemicals. For the toxicity, there are several people, as a pregnant woman or old people, who can be super sensitive for chemicals. We need to see what is the long health effect when we introduce a new chemical for the aviation industry. And we need to see if this chemical is exposed for the employees or for the passengers, then what are the future health effects. And we need to also measure how much is the volume of this chemical we are using, how frequently the employees are using these chemicals, how much do they using, is the chemical going into the air or in the surface, is the dosage less than the exposure, then we can do our risk assessment, and we can figure out how much is our risk for the future environmental protection for the aviation. Thank you.
Thank you so much. Actually, this is the on time the second round. We have 3 minutes also. If you want, I can ask the second tour question. You can answer in just 1 minute, or we can turn to audience questions. There are 3 questions now. Dear participant, please submit your questions by scanning the QR code. Perhaps we can turn to audience.
Sure.
Okay. The first question, how to remove isolation within this industry and get a multidisciplinary approach to implement sustainable aviation technology?
Maybe I can take that. The answer is I don't know. I think a lot of people don't know the right answer to this question. I know that we are trying to, for instance, here at Aviation, we had a keynote speech last year by Gaudi Bezos O'Connor from NASA. She's in charge of the electrified powertrain flight demonstration project at NASA. She gave a really great speech about how we need to bring all these people together, similar to what we talked about earlier. And then we said, okay, why do we wait people to do this? Why don't we start from somewhere? And we took action to create some working groups within AIAA. And we said, we are going to bring people that usually don't come to these forums. So most of the time, we see aerospace engineers or mechanical engineers or airframe manufacturers, engine manufacturers in these forums. We don't see a lot of airline representatives. We don't see people from the energy sector. So we are also running Electric Aircraft Technology Symposium in parallel to the Aviation Forum this year. And we started organizing panels and we invited keynote speakers intentionally from these different industries in order to start a discussion around this. So that's obviously one thing that we have started doing recently. But on the other side, we are, at MISA at least, we are making a very intentional effort to bring not only the people we already work with, such as I myself, I do research on aircraft, so I work with the aircraft or engine manufacturers from the industry a lot, but we are also trying to bring people from the Detroit airport system to campus to tell us what their problems or challenges are. We had a keynote speaker at EATS yesterday from the Houston airport system who basically told us that most airports in the US don't have the financial means to reinvent their infrastructure. They are just trying to maintain it. They are not even able to update their infrastructure. So that's a challenge that we need to be aware of, and by either, enabling these discussions by either in these forums or in our one-on-one interactions, we can start bridging that gap. But I think these are small steps that probably won't be enough without a central force, like, for instance, NASA to drive. So I know NASA has been already doing a lot on this topic, but we can only help by putting together these multidisciplinary centers, and with government support to do research, we try to bring the industry, we try to bring people from different disciplines together to work together on these problems. If you can do this in a safe environment like academia, where you can do research, then you can hopefully take this out of the academic lab study and try to apply it in real life as well, and that's what we are trying to do at MISA.
Thank you. Are there any panelists? Yes.
Yes, I think Gökçin perfectly described, but I also would like to add something from the European side. In the beginner, like a couple years before, maybe 5 years before, we were always talking about the bilateral relation between the industry and academia. Even I have been awarded one project with Turkish and Hungarian bilateral agreement, which you know, it needs to be from two bodies from two countries, one industrial and one government body from both sides. However, now if we are checking the Horizon project or CESAR project, large-scale European project, they already start going for a helix quadruple structure. That means that they would like to have at least one governmental body, one industrial body, one NGO, and in addition to this, one academia. So 4 in 1. So not only the industry and academia, now there is a support where you need to form 4 in 1. So for those projects, start getting funded by European Commission. Thank you.
Thank you.
I would like to add something
Okay.
to respond to this question also. In airline perspective, last year we established Turkey Sustainable Aviation Platform with Boeing and Istanbul Technical University. The aim of this platform preparing a soft roadmap for Turkey, and we aim to bring together all the stakeholders under this platform. We actually plan meeting with governmental side, policymakers, suppliers, and also energy companies for actually preparing for the roadmap. It's very important to establish like the coalition or corporation for achieving aviation long-term targets.
Thank you.
Maybe also a short additional point from my side. In Germany, the German Aerospace Center, means my research company, is considered as a large-scale research company. That means that we are running facilities which cannot be run in an economical, feasible way by the industry. And with the mentioned Uplift program or project at the beginning from my side, we set up such a thing where we have test facilities available up to an aircraft which we supply to the industry, especially in Germany, but also to Europe. And industry can use this facility, and the German government also supports this usage. And then industry and research come together on the base of such existing research facilities and follow a same goal and a partner by different competencies which bring up an additional benefit. And I think this is an approach which we will see in future, which hopefully works quite well, which brings together industry and academia for paving the way for a sustainable aviation in future.
Thank you.
We also have in Canada sort of like network, it's called CRIAC, for encouraging projects between companies, academia, and also research centers like NRC, which has a wind tunnel like DLR and so on, and flight test facilities. So we have the 3 players in our projects. We also are open for international projects in parallel. The only problem is always the internationals. They have academia, they have to find their own funding.
Thank you. There is another question, actually very nice. What United States export control requirements govern the sharing of technical information between SARES and AIAA partners? What kind of information can be shared? Perhaps I can say something about this question, then ask you. Actually, this panel is one of the collaboration AIAA and SARES, and next years we would like to go on these activities. I suggest some papers selected in this event we can publish our journals, or we can publish a book, Springer, some selected papers. I'm offering now AIAA management. And are there any suggestion? Perhaps Gökçin wants to say something for collaboration.
I don't work on export control, so maybe the industry partners.
Utku?
Yeah, from my side, I can tell for the information sharing part that not only between the AIAA and SARES, but also the EATS, we had very fruitful year together for the organization of these panels. I'm pretty sure that, without any border, we do this very lovely way because we have, I am partly from, can be called like DLR, NLR, and we have guy from DLR and all other companies. It is a great platform to get into same place and discuss all the topics together. So I think in the coming years, as Professor Karakoc also mentioned, that we might even go further those activities in collaboration with EATS, AIAA, or maybe all together.
Okay, thank you. There are a question. I will combine our notes, that question. What are the risks and opportunities associated with disruptive technologies like electrification and hydrogen in aviation? And here, how important is a collaboration between research, academia, and industry partners to develop these disruptive technologies?
Yeah, maybe I start answering that question. Collaboration between industry and academia is always pretty important, but especially in such a case. Academia normally has fresh ideas. Academia is not that much influenced by economical needs, but on the other hand, sometimes academia lacks a little bit the experience how to market a product and also about certification and other hard issues in aerospace technology. So that means by the end, if we really want to bring new technology into a product which is successful in the market, both sides have to be work very tightly together and share facilities which are necessary, especially for electrical aircraft. I only think, besides the hydrogen topics, also about EMI, electromagnetic interference. Nearly no aviation company has huge EMI chambers available, but academia sometimes has. But on the other hand, optimization of electronics and also electrical motors and so on needs to be done hand in hand to get by the end of the day products which are successful in the market. So for market success, this collaboration is very important and needs to be facilitated.
To add to that, at least in the US system, we really rely on the industry funding to do graduate student level research in academia as well. What that means is we need the real world problems from the industry in order to implement into our academic studies. So that we can train the next generation of workforce, but also the technologies that we develop in the academia needs a way to transition into the industry, because otherwise they are not going to be useful at all. So I see this as a must, not a nice to have. The relationship between the academia and the industry must be very strong if we are to develop technologies or develop methods that will actually be useful and make a real world impact eventually. But in academia, we have the freedom to sometimes go crazy with our ideas because we don't have the financial limitations, like you were saying, Andreas. And this can be actually a very good thing, because it lets you think freely, but also if you don't have any boundaries around your ideas in terms of what is applicable, what is economically viable, what makes financial sense, then they might never see the light of day. That's why I think there's a very mutual relationship between the academia and the industry in terms of these, in terms of research in these disruptive technologies.
Thank you. Any
Yes, I also can add something to that. That I think also a little bit about decision makers, issues, that one, because if you are considering the students, bachelor, master, PhD students, and sometimes we should promote their involvement into large-scale project, and even for the thesis dissemination part, that we should let them to go to industry. One of my affiliated university, Amsterdam University, does this perfectly, because from the bachelor level, the students need to have two supervisors, one from academia, another from the industry. And the students need to spend a minimum of 7 weeks in the industry in order to have his degree. So, but it doesn't mean that like going there and having all the papers signed and, in a fancy way, everything is done, all the required issues or hours fulfilled. It is not only that. I witnessed from the Bright Sky project that we are really having some bachelor level or master level students into our project. Both they are having practical experiments in the industry partner like NLR, Jet Support, or KLM. At the same time, also they are being part of a large-scale project, which it can open their vision. By this way, if those students going to be a leader in big, large-scale companies, they are also becoming much open for international project and academy involvement. Because unfortunately, there is some negative wave sometimes from the academia, from the industry, that academicians only know the theoretical part and the industry partners know how things is rolling in reality. Yeah, but I think nowadays it's not the case, because if you are seeing the ranked universities, they do this balance between academy and industry perfectly. Involvement of the non-government organization, NGOs, and as well as those associations related to their field, like sustainable aviation. Thank you.
I would complete that with I see two ways. I mean, there are companies in Canada, of course, hiring internship students, as you say, for 4 or 8 months internship. And in that case, profs are never, really implied in that. They are just reading the internship project at the end, and they will just give a grade and so on. So we have absolutely no impact or no opinion on that. But on the other side, when we talk about collaboration for sustainable aviation, we have this CRIAC project that I already mentioned. So these are like really projects where we try to integrate technologies like morphing, we did that, or trajectory optimization and so on, or modeling of aircraft engines. But over there, you need experimental data. Of course, we have our own equipment, as I said before, but when we go and we work with another company and we sign with at least 2 companies, an agreement, we are using some experimental data from industry. So at the moment when you are using that experimental data and you have a large group of students, like I have 40, then you put them together on different projects, and then you can really have some results which are useful to the company in that specific project. You know what I mean? So you have that team of students, bachelor, master, PhD, in your university, and they work together, and you report to industry. You have meetings like every month. Of course, you can have 1 student in company or 2, which could relate much easier, much faster, because what happens, people in companies, they don't have time to follow the work of the students. So that's what usually happens. So that's, I think, in an integrated sustainable aviation project, you can try to do the way CRIAC is doing. So they are encouraging like projects between at least 2 companies, 2 universities. Nowadays, they even put 1 company and 1 university, and then you have a specific project where all these students are working, and they can be hired after by companies. So that's the way we work in Canada. And you have also research institutes like yours, like NRC. And for some projects, really, we had very good results, because the problem in academia is, of course, the missing experimental data. And we work with experimental data of aircraft that already fly because of confidentiality issues. And then if you want to apply the technology on a new aircraft, then you take your algorithms on the other aircraft, which was validated with flight tests, wind tunnel tests, and you put it on this one. So that's how we are trying to do our work, to validate. Always it's a question of validation in the end.
Thank you.
I would like to go back to the second question, which was about the ITER control government items for privacy. It needs to be, all the documentation and regulation needs to be reviewed, maybe because it was 50 years ago or 60 years ago when the technique was planned and it was the privacy of the government. Maybe right now it's an obsolete data because the technical so much changed in the last 50 years that it's not supposed to be or should be anymore secure data. So every processes and regulations, it needs to be checked because might it cost way much more to the company because of a regulation or a process has been reviewed. And there is a restriction on that documentation which should have been already released. Thank you.
Thank you. Okay, I would like to ask another question to panelists. Do we need only new propulsion technology or radical new aircraft designs to make aviation climate-friendly transportation system?
Well, it's all of the above, I think. Ruxandra just talked about, for instance, the morphing wing aircraft, but I think it's a portfolio approach. It needs to be a portfolio approach. You need a portfolio of technologies, not only the propulsion system technologies. Obviously, that's what I work on, so that's what I usually talk about. But if you look at all the different activities that's happening right now to reach the net zero, you see those wedges in order to take the CO2 emissions down to the net zero. You see not only the propulsion system technologies, but also new airframe technologies. The truss-braced wing concept is a good example of that, obviously. But also not just the aircraft design, but improvements in the operation, the air traffic management is another part of the solution. So no, I don't think it is only the propulsion system that disruption that we need, but I think something needs to happen at the propulsion system level, because if we are talking about environmental sustainability and emissions, we need to look at the source, which is the combustion process right now at least, of those emissions. And that's why when we think about environmental sustainability, one of the very first things that come in mind is propulsion system. By itself, it might not bring us to our targets, but it's going to be the major, if not the main contributor to getting to that target, I think.
Yeah, I totally agree with you about the propulsion system. I mean, as long as we are not able to design aircraft with zero drag, we need propulsion. And if we want to design sustainable and environmentally friendly aircraft, the propulsion system is the key, since it produces the exhausts. Regarding the entirely new aircraft design, from my perspective, I would say if we talk about sustainable aerospace fuel, I would be pretty surprised if we would see entirely new or totally new aircraft design, because aircraft today are very optimized systems, optimized on the propulsion technology, on the optimized for using fossil fuel, however, but SAF is very comparable to it. So in that area, we will see improvements, but not radically new aircraft designs, from my perspective. This might be very different in the area of electrically propelled aircraft, because electrical motors, electric propulsion enables new aircraft design, because I have more freedom to place my propeller on the aircraft, because it's not that heavy anymore, and I can also very good alternate the size of the propellers. I could have more than, say, 2 or 4. And on the other hand, if you think about hydrogen, it's not that easy, not to say impossible, to store the hydrogen as the fuel today in the wing of the aircraft. So we will probably have it in a fuselage or in any other compartment of the aircraft, so we really have to think what is for this propulsion technology the optimized aircraft configuration, and this might look very different to what we have today. So, but if we talk about SAF, I think it's only about further optimization of what we already have.
Actually, we need a combination of all these implementation for the emission reduction for the future. According to the IATA forecast for future, we actually will able to use sustainable aviation fuel for achieving like this emission reduction target, but we need to scale it up. It is very limited nowadays, and it is very expensive. And it will be very, how can I say, very difficult for us to compensate like this cost in the future in an airline perspective. And on the other side, when we look at the forecast of aircraft manufacture, even 2040, we cannot use hydrogen propulsion aircraft for long base, for long hauls. And we know actually emission comes from mainly long hauls. So if we don't use hydrogen propulsion aircraft for the future, for long hauls, then we only need sustainable aviation fuel. It is very important and prominent element for achieving long-term emission reduction target. And the other side, we also, as an airlines company, we also implement improvements, operational improvement project for reducing fuel costs and also fuel saving, and also prevent the emit carbon emission into the atmosphere. But as I said, we need SAF for emission reduction for future mainly.
Okay, thank you. If there are no question and answers, before officially closing the panel, I would like to make a short conclusion. Then I would like to give some gifts from Turkish Airlines, SARES, and AIAA. In this panel, we discussed the disruptive technologies in sustainable aviation. As highlighted by the panelists, sustainable aviation is vital for reducing the environmental impact of air travel, ensuring regularity, compliance, fostering economic growth, advancing technological innovations, new propulsion technology, flight trajectory optimization, morphing technologies, electrification, and hydrogen. Overcoming these challenges necessitates considerable investment, innovation, and global cooperation. As the world moves towards the more sustainable future, the aviation industry must adopt sustainable practices to remain viable and responsible. In order to reach sustainability goals, it is necessary to focus more on the disruptive technologies. Thank you very much for your attention, question, and thank you very much all panelists. Now I would like to give some gifts from Turkish Airlines to the panelists.
Thank you.
I don't know whether Bierig or Airbus aircraft. I hope it's Bierig.
Need help, Professor?
Andreas? Please.
Oh my God.
This is from Turkish Airlines.
Thank you very much.
Have a big
Thank you very much. This is the IAA.
Thank you.
Sandra?
Oh, no, no. Oh,
This is from
Thank
Turkish
you.
Airlines.
yeah. Thank you.
The IAA.
Oh, thank you.
Thank you. Utku?
Up. Oh, wow. We have a little airplane.
Thank you very much, Professor.
Thank you very much.
I think we can turn like
You
this.
see,
Yes.
Yeah.
it's pretty, huh? I have to pull.
777.
Thank you, Professor.
Thank you.
That's the stand.
Gülşen.
Thank you.
It's what?
Thank you very much.
Thank you.
The food. You can put it on the table. Connect this to the aircraft.
Oh, okay.
Vivian?
Thank you so much.
Thank you very much. Sorry.
Thank you.
Thanks to Turkish
And Deniz, thank you very much for Turkish Airlines gift.
Welcome.
I would like to give you a IAA
Okay. No.
rosette. Yeah,
Thank you so much.
thank you very much.
Thank you.
And I would like to give all panelists to SARES rosette. Thank you so much.
Thank you.
Thank you so much.
Thank you, Professor.
Okay, oops.
I already have one.
Thank you.
Thank you.
Yeah.
Thank you. Thank you very much again. I am closing the panel now. Thank you.